In prior videos, we've learned how to set up VLANs on a switch, how to set up our switch so we can have multiple networks on that switch. But more than likely, we're probably going to have multiple switches, and we're going to want those VLANs to communicate across all of those switches. Well, that's where trunking comes into play. Trunking allows those VLANs to cross the link between switches. So in this video, let's talk about setting up VLAN trunking. In this video, we're going to get into what is trunking. We're going to explain what trunking is, and then what is 802.1q, which is what defines how trunking happens. And then we're going to get into tagging and how this 802.1q and VLAN trunking uses tagging to identify our different VLANs. So let's start out with a scenario where I don't have VLAN trunking on my network and I'm not going to set it up. Well, in that scenario right there, what I'm going to have to do is I'm going to have to run an Ethernet cable between my switches for every single VLAN that I want connected across my network. What I mean by that is, for instance, the demo laptop right here is set up on VLAN 10, the management VLAN. I also have a demo Pi set up on this management VLAN. If I didn't have VLAN trunking set up on it, I would have to have a cable. This is on an access port for VLAN 10. I would have to have another cable running from switch to switch that was for VLAN 10 and between each of these switches. So then I could be able to communicate across this network. But I'm going to have to do that for every single VLAN. So I'm going to have another cable for VLAN 20 that runs across there, and another cable for VLAN 30. And as you can see, now I'm running cables for every single connection that I have out there. Well, this could be expensive. This could be expensive because of the cabling costs. Ethernet doesn't cost all that much, but it could add up, especially if you're going longer distances. Or if it's fiber, it could be even more expensive. Or maybe it costs a lot of money to put that all into the ground, or however this is being routed from one location, physically being sent across from one location to another. It also, more than that, it takes up valuable real estate on these switches, these ports. It's taking up these ports, and therefore it's going to require us to buy more switches at each one of these sites, which can get very expensive. So that is not a great scenario. But what if what we can do is carry all of the VLANs across this single interface? And so then I just need to have my one cable that's running between each of these switches. And now, whether you're on VLAN 10, 20, 30, 40, 50, it's all going across those same lines. That is a trunk line. And we need a protocol that's going to facilitate that. But that is a trunk line, and that's what VLAN trunking is. Then we ask the question, what is IEEE 802.1q? 802.1q is what defines how this happens. How do we set up trunk lines? How do trunk lines function? And what it does is this demo laptop, we have this connected to VLAN 10. And the switch recognizes that it's connected to VLAN 10. And so when it sends it over across to the next switch, what it will do is it will take that Ethernet frame and it will slip in there a little tag into there. And that tag will say, this is for VLAN 10. So that way when this switch gets it, it can see, oh yeah, this is part of VLAN 10 and recognize that. And then it's going to adjust accordingly. Let's say this is a broadcast packet and it's for VLAN 10. Then what it's going to do, it's going to send it out all of the ports that are associated with VLAN 10. So if there's any access ports on this switch right here, then it will broadcast it out those VLAN 10 access ports. Or if this is a trunk line that has VLAN 10 on it, then it's going to send it down that trunk line because it has VLAN 10 on the other side. And then this switch gets it and it does the same thing. If there's access ports that are associated with it, this broadcast VLAN 10 broadcast packet is going to be sent out, all of those without being tagged because they're access ports. So it gets tagged only on the trunk lines here. Going across the trunk lines, that's where it gets tagged. And that broadcast then would make it out because this demo PI is on VLAN 10. This demo PI would receive that, whereas the other ones would not because they're on different access ports for different VLANs. So from a frame perspective, if you recall, this is our Ethernet frame right here. And our Ethernet frame has a destination MAC address, a source MAC address. It has a type in there and a trailer, a frame consistency check right there at the end. So this is our Ethernet frame right here. Well, what a 802.1q frame looks like is we just slip in that tag in between. So right here, we've slipped in the tag in between the source MAC address and the type field right here. We slip in that tag with that VLAN information and then send it across that trunk line. And then it gets over to the other switch, and that other switch sees that, aha, I know what VLAN this is a part of because I can see the tag. The tag that gets inserted is 4 bytes, and it looks like this right here. So the 4 bytes consist of 2 bytes of this tag protocol identifier. There's also 3 bits of PCP or priority code point. There's a DEI or a drop eligible indicator. And then there's the VLAN ID. Really, what we're mostly concerned about right now is this VLAN ID, because this is really what we're talking about, where it's tagging the VLAN information onto this frame before it sends it along. One thing to note about this VLAN ID is that it is 12 bits long, or that is to the 12th. So if you recall, when we're talking about binary, every bit has 2 possibilities to the 12th power. That means this actually is 4096, which is similar to how many VLANs we can set up on our Cisco devices. This is not by mistake. This is why that there's a limit of 4096 VLANs on our devices. And just a little refresher on those VLAN IDs. Don't forget that VLAN ID we have of 1 is the Cisco default. The 2 through 1001 is our normal range. We got the 1002 through 1005, which are devoted to some other protocols. And then we have 1006 through 4094. So there we have about 4096. One of them is 0, which we don't use. And then the other one is 4095, which we don't use either. So there is our VLAN IDs that fit into that VLAN tag. So there you have it. That is VLAN tagging. Pretty simplistic, really. It just takes that 802.1q, defines what VLAN tagging is, takes that VLAN ID and inserts it in there and sends it along its way.